Hi everybody, welcome to my video. Today I'm going to be talking about the mathematical jokes and references in The Simpsons. Now, as you probably know, The Simpsons is absolutely jam-packed with mathematical Easter eggs. And why? Because the writers are actually mathematicians themselves. You know, Matt Groening, David X. Cohen, Al Jean, they're all mathematicians. And they've put in all these kinds of mathematical secrets that I'm going to talk about today. Now, the reference I'm going to talk about today is a reference to Fermat's last theorem. And it's not just referenced in The Simpsons, it seems like Homer Simpson, our donut-eating, beer-drinking character, has actually disproved it. So, firstly, what is Fermat's last theorem? So, we have Fermat's last theorem, and I hope you guys all appreciate my badly drawn Homer here. It's Homer after he's had a few beers, so we can all relate probably. So Fermat's last theorem states that we have x to the n plus y to the n equals z to the n has no integer solutions for when n is greater than 2. So if x, y and z are different integers, there's no integer of n where n is an integer that's greater than 2. So why greater than 2? So I'm going to introduce this using our trusty right angle triangles that you've probably come across if you did maths at GCSE or even before that. So I'm going to draw a nice simple right angle triangle. So this is our right angle triangle. So we have our right angle triangle and we're going to do a Pythagorean triple. A Pythagorean triple, you may know this as the 3, 4, 5 triangle, which means if we have the two shorter sides as 3 and 4, the length of our hypotenuse is going to be 5. So if I just draw this onto our diagram, so you guys can see. Now you're probably all familiar with Pythagoras' theorem, maybe from if you did GCSE maths or from any kind of science-based subjects. So Pythagoras' theorem is a squared plus b squared equals c squared, where a and b are our shorter sides and c is the length of our hypotenuse. So if we plug these numbers into Pythagoras' theorem, we get 3 squared plus 4 squared equals 5 squared. So this actually looks a little bit like our Fermat's last theorem. Look at how x is 3, our y is 4, and our z is 5, and our n is 2. But obviously this isn't a solution to Fermat's last theorem because n has to be greater than 2. And it turns out that there are no solutions for which n is greater than 2, and this was solved in 1993 by a mathematician called Andrew Giles. And he said, you know, there is definitely no solutions. He did this by solving what we call the Taniyama-Shimura conjecture, and hence from that he was able to prove Fermat's last theorem. However, this is what's interesting. In The Simpsons, there's an episode called The Wizard of Evergreen Terrace, where Homer decides he's going to become an inventor because he's inspired by Thomas Edison, and he makes these god-awful inventions. He makes like a toilet chair, and a makeup gun, and an electric hammer that don't really work. And during the episode, he's writing these equations on a blackboard. And it's a very, very short sequence, perhaps it's only about 5 seconds. But one of the lines on the blackboard is very interesting. So if we have a look at this blackboard equation, now the top equation, just a little fun fact, is actually the formula that predicts the mass of the Higgs boson. Now that's not that strange, apart from this episode came out in 1998, so that's before I was born. And the Higgs boson was discovered in 2012. At this point, they hadn't even began building the Large Hadron Collider. And a lot of physicists speculated that it didn't exist. There was a lot of controversy about it. So for them to put the mass of the Higgs boson in here, it's a little bit intriguing. I know The Simpsons has a reputation for predicting events that have happened, like the episode where Trump becomes president, and that episode aired in 2000. So I think this might be another kind of prediction. But on to the second line. The second line is what I'm going to call Homer's last theorem. Homer's last theorem. And when I first saw this, I thought it was just some random integers put together to look like a solution to Fermat's last theorem. But actually, if you check this out on a calculator, perhaps a phone calculator, not a very powerful calculator, this does actually check out. And I'm going to prove this now. 4,472 to the power 12, I've worked that out. And it is this number here. So it's 6.39766563 times 10 to the power 43. And then I've got my phone calculator, and I worked out the other side of the equation, and it gives me this. Now, it's not quite. So in the version I worked out, the last digits were 563, and in this one the last digits are 655. So it's just out. Now, it was actually quite relieving to hear this, that Homer Simpson hadn't disproved Fermat's last theorem, but this is actually what we call a near-miss solution, so it's not quite a solution, but it's very, very close. So although Homer Simpson didn't disprove Fermat's last theorem, it looks like he came very close, and we should give him a little bit more credit. Luckily, Fermat's last theorem doesn't have any integer solutions, which is very lucky. The Higgs boson, I'm not sure about that. I think that's kind of spooky that they predicted the Higgs boson so long in advance. It's a little bit crazy. So thank you very much for watching. I hope you enjoyed it. Please click that like button if you like this, and don't forget to subscribe. I have so many more maths and physics-based videos coming up for you. I'm also going to do some videos on applying to university. Please subscribe, don't miss out. There are videos every single week. So, goodbye, and may the force be with you.